The last lecture we were taking up the design of two-way slab for a load of. This is the question that was given to you. So what we did, we calculated the thickness of the slab, then we provided, determined the effective length, then we calculated the loadings. Uh, from there, we calculated the loading, and then we were on the step where we were determining the movements in the slab. How do you determine the moments in the slab? I discussed that when you go through Rankine-Gross method or through the Marcus corrections, which are based actually on the inelastic theories. So, but we have to implement the code. They are based mostly on the Marcus corrections. So thereby, so we'll be implementing the code while doing this question, and this is what we are going to use. There, what is this thing is that next we are going to determine the moments in the slab, and now this is your slab. Now in this case it's simply supported on the edge, thereby the moment at the edge is zero. uh, what is the moment at the center? Now there are two directions, as we know. This is x direction and this is y direction for the slab. Along this direction you have Lx, the length, and along this you have Ly, the length. Similarly, you would have movements about this direction, which would be mx, or capital M and x, and you would have movement about this direction, which would be my. Now what does the code say about this? For shorter span coefficient, alpha x, these are the coefficient, and for the longer span, that's alpha y. So we have used this right terminology. We have used x direction along the short direction and y along the longer direction, Lx and Ly. Now what is mx? Mx is, as per code, is this per unit width in the slab. So that's, this is for 1 meter strip at the center of the two-way slab. So you need to understand that what we are talking about is there is a 1 meter strip here at the center of the slab along this direction as well as in this direction. So when we are saying mx, that will be along this direction at the center of the slab, and this is again 1 meter in width. It's a strip of 1 meter. Again, this is 1 meter in strip, and we are calculating my about this direction. Now, what would be mx? It is alpha x, as you saw just now. Let me copy this. This is mx alpha x into wl lx square. Thereby, mx would now be how much did we get Ly by Lx last time? It was 1.64, 1.64. So we need to determine alpha x first for 1.64. For 1.5, for 4H discontinuous, there is only positive moment at the midspan. For torsionally restrained slab, this is 0.089 and this is 0.1. 0.089 corresponding to 1.5. 0.089. Alpha x का value is, this is the value of alpha x, 0.089 for 1.5, and it is 0.100 for 1.75. This is the value of r, or Ly by Lx, for r value of 1.75. Thereby, can you now determine for r of 1.64? How do you do that? What is the unit change of the value of alpha x? What's the unit change of it? Zero point 0.1 minus 0.089 is the change in, over what? Over how much of a change in R would you have this much change, the unit change? That is from 1.75 minus 1.5 for this value of R, changing from 1.75, 1.5 to 1.75. This is the unit change in R. So this would be how much? 0.1 minus 0.089 divided by 0.044 is the unit change. This is equal to 0.044. So for r equal to 1.65, it would be, what is the value at 1.5? It's 0.089 plus, what is the unit change? 0.044 into, what's the difference between 1.64 and 1.5? 1.64 minus 1.5. So how much would this be? So it's 0.095. So the value of this would be 0.095. What is this value? For corresponding to R of 1.65, this is the value of alpha x. This is alpha x. Okay. So similarly, now you want to get alpha y. The value of alpha y is, it's 0.056 for all values of Ly by Lx. So that's 0.056. Alpha y is 0.056. Now you have the values of both alpha x and alpha y. Lx is already known to you. What is the value of Lx? Lx and Ly are the lengths of the short span and the longer span. Now, in this case, this has to be taken as effective length. Lx, how much is that? Effective length of Lx, if we had already calculated this, that's 3.122. So it's actually LEX while you are calculating the moments. So here mx would be equal to alpha x, just the value हमें we just got it 0.095 cross what is the value of the load that you need, W. What is the total load over a span, which is, I'm talking about the span where you have the factored load. Now this will be an area load over this portion, 1 meter square. And how much did we calculate that? It was 14.415 into LEX, which is 4 point, that is 3.122. This is 3.122 and its square. E value are at 0.095 cross 14.415 cross 3.122 3.122. So this is 13.35 kilonewton meter. So over that 1 meter strip, over 1 meter strip over which you are calculating at the center of it. Now along the edge, along mx direction, the moment is here 0. Similarly, my would be, what is the value of alpha y? 0.056. This is 0.056 cross 415 cross. Again along the x direction itself, because both have been resolved along the x direction. 7.86. This is for 1 meter strip of the area. So mx and my, you now know this will be at the center of this slab. Along mx would be along this direction and my would be along this direction. Now we would say that along this direction you would have the greatest amount of moments at the center. Yes, but they are transferred then to the shorter direction. So whatever you are getting as mx is actually the rotating couple about the longer direction, but it's taken across the shorter direction. Similarly, my is along the shorter direction but taken across the longer direction. Thereby, now how would you then, what is the next step? We have gone from step number 1, 2, 3, 4. Our next step then is to calculate the area of steel for this section. Along both the directions, you have to calculate the area of steel separately. Now, along the direction of AST, along the direction of X, AST would be calculated for mx and asty would be calculated for my. What formula do you use for that? Yes, any issue, Faizan? Faizan,
Yes, sir.
what's the issue?
The page number 97, 91 पे है ना सर, टेबल नंबर 27B.
Yes, this one.
जी सर हमने ये क्यों नहीं यूज किया, क्योंकि ये तो सिंपली सपोर्टेड केस के लिए.
Uh, मैंने दो चीजें कही even in the last lecture. If it's not restrained, torsionally restrained, then you can use this table. If it's torsionally restrained, you are using this table. This is for torsional restraints at the corners. So this is also a simple support condition. 4h discontinuous. You will only have positive movement at the midspan and zero movement at the ends. So you can use this one when you have torsional restraint. Corner आपके restrained है. They are not being allowed to lift up. Why? Because we are providing corner reinforcement here. And in this case, when we are using this, we don't go for corner reinforcement here in this case. So the corners can lift up. So there is a possibility of rotation of the corners. So there is no torsional restraint at the corners. This is as per the question. I told you in the question that we are doing simple support on the four sides, but with torsional restraint. Now from code, you already know going to a G portion, you will be using the same formulation, this one. There are various formulations you can do in terms of R and others, even in the beams as well as in the slabs, but this is the simplest formulation I use. You go with this formulation, and this formula is valid for slabs which are under reinforced. So this is the formula that we are using for. Now your mu is along the x direction, that you already know. This is mu. It's already factored 13.35, 10 raised by 6. This is along the x direction we are calculating. AST, this is 0.87, 500. STX into D. D was 160, or that was overall D, 122. Then you have 1 minus the value of AST, 500. This divided by cross D. D is your, again, 1 meter strip of this over. Now your FCK is 20 or 25? 20. This is 20, and this would be, what would be the value of ASTX now? Calculate from this at your own places. What's the value that you are getting?
4613.94.
I'm getting two values. I'm getting 251.56. Yes, anyone else? I'm getting 251.56. It will not be this much. You will always have two values of this. Second value क्या है? This is the value I'm getting.